Alright, I'm excited because this is the first math video I get to make for you on algebra. And, well, let's celebrate. Let's go ahead and get the balloons going here. That's a black balloon there. And let's do another one here. Black balloon here. And fireworks that are black also. Fine. Let's add some color. Anyway, first lesson on algebra. What is algebra? Algebra is simply, and this is super simply, math with letters. We have a special name for those letters. We call them variables. Variable. And a variable can be any letter. That stands for a value. Anyway, here's our goal for today. The objective is to write mathematical expressions. So let me underline mathematical expressions. And we're going to go ahead and write mathematical expressions for verbal expressions. We're basically transforming verbal expressions, which is another word for words, into mathematical expressions. And, well, for this one, algebraic expressions. And all mathematical expression is a number or more, okay? So like 1 and let's say 2, with an arithmetic operation, such as addition. So 1 plus 2 is an example of a mathematical expression. So we're basically translating English words to mathematics, in this case, as something as simple as 1 plus 2. Let's go ahead and take a look at our first example. 8 more than a number. More than. That's the tip-off, because that tells us the operation. Well, what if your sister was 2 years more than I? Or was it 2 years more than me? This ain't a language arts class. Anyway, more than means addition. And 8 more than a number, well, that means it's going to be 8 being added to a number. And, well, our number here, we have to go ahead and use a variable to define that. And let's go ahead and call this number m for me. Okay? So 8 more than a number m is m plus 8. And that is the algebraic expression for 8 more than a number. It has one or more numbers, or variables in this case, m, and an operation that's arithmetic in between. In this case, it's addition. Alright, example number 2. Whoa, this one's already been used up a bit. So let me go ahead and erase that real quick and get back to it. Okay, this is actually take number 2, so that's why some of this stuff's already filled out. Now this one's a bit tricky because we have 7 less than the product of 4 and a number x. So we actually have less than and product. Now 7 less than the product. What operations are suggested here? Product is multiplication, as you can guess. You probably already know. And less than, well, less than actually has a couple of possibilities there, but in this case we usually think of subtraction with that. So we have both subtraction and multiplication involved. And, well, let's see, is 7 less than, does that stand for 7 minus, or does 7 less than stand for minus 7? So 7 less than. Well, what if we said, or asked, to tell me what the number is that's 7 less than 10? And you would answer, first thinking, 7 less than 10 is 10 minus 7, which is, well, 7 less than 10 is 3. Now, let's go ahead one step further, and I say, pick a number that's 7 less than 100. Well, pick a specific number. And 7 less than 100 is going to be, well, 100 minus 7, which is 93. So you can see that 7 less than stands for minus 7. So it's actually this one here and not that one. So we're going to take away 7 from something. And what are we going to take away 7 from? Well, it's the second part here, the product of 4 and a number x. Well, we know product stands for multiplication. And we have 4 and a number x. Well, 4 and a number x, or 4 times x. And you can probably go ahead and simplify it. Anytime you have a number multiplied by a variable, you can leave out the symbol of multiplication and just write it next to each other. And 4x minus 7 is the 7 less than the product of 4 and a number x. So be careful here when you have a subtraction. Order is important, and it's important to figure out, is it minus something or is it something minus? Anyway, third example, a little bit simpler in that, and again I have to erase. There we go. 1/3 of the original area A. Now you're thinking, oh, area, that's going to be a formula. But we don't know what shape we have here. And we don't know what the dimensions are of this shape anyway. So we really can't do anything with the area. We just have to go ahead and say that A will be the number that stands for area, whatever it is. And 1/3 suggests that we have a couple of things, possibly. 1/3 could be the fraction 1/3, and an of the is multiplication. Well, multiplying 1/3 times our area, in this case A, or 1/3 A. 1/3 can also be translated to 1 divided by 3. Okay? And what are we dividing by 3 essentially? Well, we're dividing A by 3. So here's another way to write 1/3 of an original area A. But if you want to change A divided by 3 into a fraction, you can change it like A over 3. And that's a third way to write this expression. So the verbal expression was 1/3 of the original area A. You can use that as multiplication, 1/3 times A. Or you can use 1/3 as a understanding of division. So anytime we have 1/3 of something, you're dividing it by 3. So A divided by 3, and anytime you show division of two things, you can write it as a fraction, in this case A over 3. Uno mas. Okay, this is a long lesson, and I like to keep them less than 5 minutes, but deal with me here, and there's a quick preview of what we're going to be doing. And here we go. The product is 7 and m to the 5th power. Product. So product means, you guessed it, multiplication. 7 and m, oh, that's what we're multiplying. 7 times m. And, oh, the 5th power. Now, we have to figure out what's being taken to the 5th power here. Is it the m? Well, if that's the case, then m to the 5th power looks like this. And you can simplify 7 times m to the 5th power as 7m to the 5th, like that. But wait, what if they're doing the product of 7 and m to the 5th power? What if the entire product of 7m is being taken to the 5th? And you might be asking yourself, isn't that the same? But actually, what you'll learn later on in algebra, or maybe you've learned it in pre-algebra, is that whenever you take an exponent that's in outside of parentheses, it distributes to both items inside the parentheses, and this value is actually different from what we had before. This would be 7 to the 5th times m to the 5th, and that's some highfalutin number. I don't know, let's say it's a big number. I'll pause here and replace the big number in a sec. Okay, here we go. And then, of course, m is being taken to the 5th power. And that accomplishes our objective of showing you how to change verbal expressions to mathematical or algebraic expressions in this case. Let me know if you have any questions in class.